Okay, so we defined the Turan graph Tm and sub n of k to be the complete m-partite graph where all the parts, so you write n equals k times m plus r, right, as a division algorithm. And all the parts have size either k or k plus 1, okay? So there's r parts of size k plus 1, m minus r parts of size k, yeah? And we want to prove that the number of edges in this graph is given by n minus k choose 2 plus m minus 1 times k plus 1 choose 2. Yeah? Got it? Okay, so this is the way we do it. So if you just count it your own way and do the algebra, I think it's pretty difficult, yeah? But for r equals 0, it's a good exercise, yeah? But here maybe a good conceptual way. So you have basically all these parts that have k things in them, right? And then you have all these parts with k plus 1 things in them, yeah? Yeah? So this term here, m minus k choose 2, yeah? Is basically deleting this part and then connecting all of these things together, yeah? But also internally connecting. So every two vertices are connected now, yeah? Okay. So then to get the actual number of edges, you gotta add the connections that go to the deleted part, yeah? And you gotta delete the connections that are internal to these other parts. Yeah? Okay. And hopefully when you do that, the difference is this m minus 1 times k plus 1 choose 2. Okay? Okay, so how many connections going to k, right? Well, there's m parts altogether, yeah? R of them have k plus 1 things in it. So if you subtract the ones with k plus 1 things in it, there's m minus r things with k in them, right? You subtract the one you deleted, so those are the other things with k things in them, right? And those, like the number of edges joining k things to k things is k squared. Yes? It's k squared, yeah? Okay. So that's how many edges you need to add from the things with k vertices in them. Yeah? Okay. And then I said there was r things with k plus 1 vertices, and k plus 1 and k make rk times k plus 1, right? So those are the two things we need to add. Yeah? Okay, then we need to subtract the internal connections in each part. Okay? So, for example, we need to subtract. So there's r parts where there's k plus 1 things in each part, right? And those number of internal connections is k plus 1 choose 2. Because you're just choosing two of the vertices out of the k plus 1 to connect. Yeah? This is k plus 1 choose 2. So k plus 1 choose 2 is actually just this. Yeah? Okay. And then, what about the internal connections of the other k things? Well, there's m minus r minus 1 of those things again, right? And the internal connections is k choose 2, because there's k of vertices, and you want to connect every pair. Okay? So it's k times k minus 1 on 2. Yeah? Okay. So now we can just simplify this two expressions and add them up, yeah? So here we have a lot of common factors, yeah? So in fact, this is just half of that, right? So this is just r times k plus 1 on 2, yeah? Okay. This one here is got a lot of common factors again. K, and let's put a half out here, and then it's k minus 1, yeah? Which is just 1, yeah? Okay. So then we just add these two things together now. Yeah? Well, if you add these two things together, did I miss something here? There should be a k plus 1 here. Oh yeah, this is a 2, right? This is a 2. Because I put a half. Yeah. This didn't have a half, so it needs to times by 2. Yeah, so this is k plus 1, yeah? Yeah? So if you put them together, so k plus 1 times k over 2, that's k plus 1 choose 2, right? Yeah? And then you're just adding this part to the r, yeah? So it's m minus 1, see? M minus r minus 1 plus r is m minus 1. Okay, so then you get it, yeah? Indeed. Yes, a good time to have dinner now. Yes.